Hello everybody, it's Damon. Crazy Logics 007 on YouTube and Crazy Logics in the forums. Back on this Rockford, finally. We'll show you, ba-bam, new oscilloscope and matching power supply. Got a deal on those. And so that's going to help me troubleshoot this. My old oscilloscope was just giving me fits. And so I've been looking for one for weeks and weeks and weeks and weeks and weeks, and just stumbled across this one and got it. So where we last left off, we'd set the bias and the original factory channel looked pretty good, but we did not get good output from the other channel that we have replaced the FETs on. Now the screws were in here only bridged, but I did touch the outputs there, and definitely one was maybe working a little and the other not so much. So this new scope does, if you see up here in the corner right there, that little red thing allows me to do a better job of moving my ground. I had to use an old BNC connector and all this other stuff, but now I can use different ones. Let's see if I can use different plugs right here on the front, and it's got a ground connection for my reference on there, and so that makes things nice. So let's pump. We should have sound on, so we take our O-scope, and I'm feeding it into all these, and I should. There we go. Got a 60 hertz sine wave. Now this is with no power on it, and that's right into the RCA's front and back, and that allows us to compare these. So we've got power, and we're going to power it up, and we'll probably have to adjust our voltage a little. Now let's go here. So this is on the back of the FETs, and you can, helps if you hold the remote power on. My foot switch was not in a good spot. So there's a little clip on that one, a little on that one. That one looks good. That one looks good. This one's got a little deformity on the bottom of the wave, but I can tell you why that probably is. So we'll look at this other one. See, it's all clipped up bad, not driving right. This one's all kinds of goofy. We got all kinds of goofiness going on. When I was prepping to do this and fighting with my old oscilloscope, I noticed, and you'll see right here, green tape wrapped around the gain control. I had cleaned the switches and cleaned the gain knobs and everything, and this one's just floppy loosey, and I can't get it consistently show up. So not only is it impossible to match to this other one so that it makes easy comparison readings, but the two wipers inside, which one is controlling each of these sets, is uneven and not working correctly. So that's probably why it's driving this one side into clip and this other side not. So what we're going to do is we're going to look at this a little bit, and I'll show you the signals in a couple places and kind of how I trace this out. And then we're going to go through, and because we had to replace this and this gate resistor for these two FETs, the 9605s or 9650s, we're going to go ahead and replace all these drivers just to make sure. Now, and then we're going to replace this one, and we also need to check one other thing I want to show you how to check. So let's do that. We're going to have no power. You got to unplug all your RCA's, and I just used an old RCA jack that allows me to get a clamp on the ground. These are all shared. I'll show you that. We'll turn our meter so you can see it. So we're on continuity. See, the outside shield is all shared. So I can use this one little old taken apart RCA and clip my oscilloscope onto that ground to get the input signal ground. And the input signal ground should be different than the main ground. So on the power supply, you use your oscope, you will want to reference this to the main ground. So I would take my clip here and I would clip it over onto the ground, which actually over onto my power supply. But one of the things you need to do is Rockford's should have at least a 1K resistor and like a diode and a cap that go that separate this ground from the main ground. So when you take a reading, you're going to see it's going to go up real slow. That's because it's charging a little cap that's all in parallel there. But that's their little noise isolation circuit between main ground and the input ground. And it's going to keep charging, so we're getting close. I got it on in the thousands here. It needs to get close to 1,000. That's pretty good. Now if we switch it, it should read what a diode would read. Pretty close. Yeah. Okay, so we don't have anything dead, and I happen to know that ground setup runs right through the middle of this board towards the actually towards right in here. It is this little cap, this little resistor, and this little diode. And let's see if I can get zoomed in here. We'll turn it sideways if it'll focus, and then I'll switch. Give me a second. Right there. Okay. So it happens to be R41 in this amp. The diode number is D3. Yeah, D3 and C13. I don't know if this is what they consider their topaz elimination circuit or what. It's pretty simple. But if you don't have diode reading and about 1,000 ohms, even though this R41's turned upside down, this amp is bad about having tons of its resistors installed upside down. Man, I am shaking. Can't get a steady rest there. Let's see, does that work? Maybe. When I'm talking, it shakes. But you want to make sure this cap, that diode, and that resistor are okay. If somebody touches, and let's go back to the, if somebody touches battery positive to anything on the shield, either up at the radio or back by the amp or anything, it'll blow that little section, which is the isolation between those two. So we just tested it, and so that tested good, but I started to worry since we've not only had blown channels, we had to repair the RCAs, which looks to be physical damage, and we're going to have to replace this pot here with another one I've got here. I wasn't sure. I wanted to test that because, you know, it's already had some physical damage from an impact or something yanking on it, which has made this pot bad and made it where we had to repair this. So I wanted to make sure it hadn't touched a power wire too and blown that little circuit out, which helps with noise rejection. So that being said, we're going to take this sucker out. We're going to remove this pot and replace it so we can easily compare all these and get this side to stop freaking out and one side driving a little more than the other because that pot is so goofed up. And then we're going to replace these 4 driver transistors. These are what drive this. And so, like I said, I can measure on the back there and see that they're not getting driven correctly. And since we had to replace those 2, I would say it's this and this transistor, this drive transistor, but we're going to replace all of them just to be safe. And then we'll check it. And then when we get it all done and it's all up and working here, I want to show you the actual working gate leg drive, because they don't look anything like on a Rockford's MOSFET setup. I'm not, you know, an expert on Rockford at all. I like working on them, and they just work. And if you know kind of what components to replace, you know, going back a little bit, they work. But their gate does not look, you can't make anything show up realistically on the oscilloscope that I've found yet on their drive because the way it does it so fast and does it for a MOSFET. So Rockford's really cool in that way, that these little chips that drive it, or sorry, when the op amps drive through all this little circuitry that they've got here, and it does feedback and all kinds of stuff, really makes it cool. But normally it's just these transistors that die, so we're going to get this sucker out of the board, and we're going to do that work. Oh, we got to do something first before we do anything else, but I'll go ahead and get these screws out. I'd already taken a few of them out, trying to get prepped to show you all this. And then the other thing I wanted to show you, and I'll try to do it before the end of the video, is all these op amps. These op amps are what bring the signal in, and you adjust gain and your crossover frequencies and stuff. So this board is really well laid out for that. But since it's 4-channel, you can see the mirroring of the layout of the op amps. So these are the first couple of op amps that come in. They go over to here, and then this would be the final little op amp before it goes into the circuitry. So each op amp's got 2 channels, and so it actually works real good in a 4-channel amp. It'll be sending one out, and it actually goes out through this little cap here and out through that little cap, and then down through the rest of the circuitry. And then the same on this one. It goes out this little cap and that little cap. They're not exact perfect mirrors, but they're real close. The nice thing about Rockford amps is if you look at all these little numbers on the board, let's see if we can, if you look at all those numbers on the board, see how that one says 4, like, Q415. There'll be a Q415, a Q315, a Q215, and a Q115, all in here. So one is the 100s are all in one channel, the 200s are all in another, the 300s and the 400s, they might be a little swapped around on the numbers. I'm just throwing them out there real quick. But that can really help you because you can take some measurements in a working channel and go to a non-working channel and follow those same part numbers, except from the 400 to the 300 series, and follow that through and be able to do that. And so that's what makes anytime you have one working channel at least on any amp, it helps you once you identify each side, because they're normally mirrors of each other, and one side will be inverted for bridging. So on this, one side of this will actually technically be this side, and one will be the other side, and they're inverted so they can be bridged. But like I said, we're gonna take that out. I want to show you the signals of these coming out when we're done, and then all the way up here, you'll see clean signals hopefully once we're done, and then you'll see that the drive, I just haven't figured out Rockford's really cool little circuitry that drives FETs in a way that makes it to where it's hard to see the gate. Whereas if this had been transistors in a standard class AB, an older style, which I'll do some videos on, I got a few of those amps that we'll do, you'll be able to see the sine wave that you feed in, or the music, perfectly on the gate leg, and then on the output it'll always be perfectly just a higher amplitude of that. So on the Rockfords it's a little different, but okay, we have got that out. We're going to pull this out of the way. Oh, and there's one last thing we desperately need to do, and that is this. So this is the side we're going to be taking out of, and so I've just taken me a little scrap of paper and kind of drawn out where those are at. And so if you shine your light, that is an A56. That's an A56. This one is an A06. This This one is an A56. And that one should be an A06. Yep. So just make you a sketch so you know where they go. I've got the part numbers here, and I wanted to make sure I showed them to you. They are an MPS A06 for the A06 ones, and an MPS A56 for the 56 ones. And so, see if you can see that. Yep, there's all of them. And so we'll just replace those. And I always do that so I know which ones go where, so I can plug in the right ones. And what I'll do is I'll open up only one package and we'll stick in two. The two that are correct, we'll remove all of them, but we'll stick in the two that are correct. We'll solder them in before we open the other package. That way we can't get confused or have one drop out or anything like that. So we are going to go for removing this pot right here. And I've got my soldering iron heating up. Let's make a little room on the workbench. Get some stuff nice and kneaded up here. And I might be able to bring you in a little closer. Not much. I really, really want to be able to get a little camera that somehow I can float still there to give you some close-ups, because I know that's what would help me when I started learning this, and obviously I'm still learning. It's just a hobby, but being able to go in there. So we're just going to add solder to all these pads. And we're going to get our old man glasses, and we're going to center this up a little better so I can see it good. So we can try this one of two ways. Now that we've added some solder to everything, we've got all that new thermal compound on there. My poor chair is falling apart out here. I'm going to have to do some work on it. So there's a couple ways I do this. Whenever I got very few legs, sometimes it's easiest just to get the solder so blobbed that you can get it all heated out and then drop this out. Other times you'll need to suck it out. So we're gonna try to see how well it sucks out. Not too bad. Yeah, it's not wanting to suck very well. I've got some silicone put on the end of this thing, trying to work, but it's actually better for bigger stuff. So I'm going to grab the solder here. We're just going to add enough solder to get this to start to flow and bridge. See how we made a big old solder goober there? Let's grab this one. Let's get close and go full screen. See how I've connected all the pins with solder. So now I should be able to get a little plier, and we should be able to lay our soldering iron in there and just heat all of that and give it a gentle wiggle until you make sure it's good and heated, and it should just drop right on out. Ba-bam! So now we got the old one out. And you always want to inspect it to make sure there wasn't any vias get pulled, but normally if you wait and you feel it all get loose, it's a feel thing. You'll be fine. On small stuff like that, that works really well. Okay, so we need to get a little bit of, boy, that one's all used up. There's a little bit on this one. All right, getting thermal paste all over me. Let me find my new braid. I've got some new braid. And then the other side is these that we need to do. So that was that, and then there, and that one. And there, and there. So let's work on adding a little solder to those. This one's got bent over legs. So let's do another show. Let's see if we can get in. Okay. See how the legs are bent on that one? We're going to want to, when we add a little solder, straighten those legs up so we'll be able to pull it. So you just add a little solder, get it a little liquid. Sometimes you can get underneath there with the tip of your soldering iron. Other times I have to take my razor knife, get the solder liquid, and just give it a little up. I need to add more solder there. I don't know how well you can see this. I need to adjust it there for you. I'm going to definitely have to work on my camera setup and stuff to make it to where we can see down in here a little better. That's straightened up. And that one's straightened up. Oh, I hate these. The part I hate about these mesh strips is that they're all up in your stuff when you're trying getting thermal paste all bad. So these three I'm going to add solder to, because we're going to be removing that. And right there, these three. And what's the last one? Right there. So this one, and this one. I don't have my wooden stick. Oh, take a cast aluminum nugget, stick it under here to help hold that at an angle. So I get a hold of it on the bottom with a pair of tweezers. I'm gonna add some more so that we can flow back and forth. Get a hold of it. And you get it to where it slides right out of there. And so I'm going to do that to the rest of these. I'm going to pause it for a minute because I need to sneeze. I'm about to sneeze. I'm going to undo the others, and then we'll clean the board and we'll install the new ones. So give me a moment's break here, and when we swap back, I should have pulled these real quick, and I'll save the board cleaning because I want to show you guys how to clean up the board and make it all look nice. And I got to find my new braid. So give me just a moment. magic transition, you know, something fun. I don't know. Probably won't be. Okay, kind of got you set up here a little angle over here. I've got the other camera set up. Switch over to it. Here is where we're going to be taking out some of the solder. And I tried some cheap solder wick because I had lots of old flux that I wanted to get used up, and I thought, man, I wouldn't get any. But this Chemtronics is the only way to go. So I ordered more of it. It was my new roll I'd ran out. So we're gonna these 3 pads, and so you just apply a little heat right on the very end. Oops. And you see it getting silver, and bam, that hole is open. And you just continue on that way. You'll see it turn liquid. And if you don't get it all on the top side or on the bottom side, you can always flip the board. And so sometimes you have to keep snipping off a little bit so it's easier to heat your copper. Because you just want it right on the end. There, a little more. There, perfect. Go ahead and hit this one, and it's sucked up a little more, and perfect. So now you can see all 3 of those. So let's go back here. Chemtronics, definitely the best solder braid to get, or there's probably another couple brands that are really good, but man, this stuff just works. The cheap stuff I got, I can use my flux with it and stuff, and it's fine for big stuff. But man, when you got to do little bitty holes like that, buy the good stuff. It makes a huge difference. So I'll probably keep some of the cheap stuff for doing big things like FET cleanup, you know, the cleanup of the back of mesh boards and stuff when I need to get rid of a bunch of solder. But I'll definitely pay the little extra to get the good wick to be able to do that good a job right there on that. Let's see if I can. No, that's not what I wanted. There we go. Here's where the pot was. And so we've done that. And so what we'll do after that is a little 91% isopropyl alcohol, some Q-tips. Put in a silver bowl. I've got all the screws in here, but I'll dump them out. And so I just add a couple squirts, get my isopropyl alcohol, and clean those areas up. That gets rid of all the flux residue and cleans everything really nice. I always do all my preliminary cleaning with isopropyl alcohol, and then I use acetone, just plain old acetone. I put it in this little bottle. I got these came from IKEA. They say IKEA on the bottom. They're really good snap top lids. So I put my water in it and my acetone, and that way, because you don't want liquids going everywhere on the bench, those stay sealed and don't spill. So it's been really nice. So I've got that one done, and then I'll do this one, and this one, and I'll clean them up. Let's go ahead and flip it over to the back side, and you would clean the back side just the same way. And sometimes you got to get a toothbrush to clean everything up, and sometimes you'll notice a little bit of hardened solder get somewhere, and you'll have to catch it a little. But I always clean. Makes it so much easier to work on. And then if you end up with a hot air rework gun for doing chips, you can also turn this on real quick, blow it a little bit on there to help evaporate the alcohol and water really fast if you're needing to be in a hurry. But I'm going to go ahead and do those other 3, and then we will be ready to do it. I'll snap back to the install, and I'm trying to keep this video precise and neat. then I tend to go real long, and I know that's a bother for some people. So I'll clean those up off camera, and then we'll be ready to drop in some new components in this new piece. We'll do that real quick, and then we'll see about testing it. All right, so got the holes all cleaned up. We're going to, oh, I wanted to show you. I'll see if I can grab these here. Whole bunch of snips off on the ends when you're using that solder wick. That show up my camera good? Yep, okay. I'm trying to use my other camera here to let you see. So we're going to look at our sheet, and we're going to get the 56 out here. So I've got them out. And so 56 goes here and here, so it's going to go there and there. So we'll get them off here. And we get our specs out and make sure they're 56s. Yep. And so we're going to put one there. And we're going to put one there. Tight fit right there. There we go. And I'm going to reach up under the board. Maybe you can see this. I'm going to bend these legs, just by feel even, out a little so that it'll hold it. There you can see they splayed out. And we're going to go ahead and flip this. Soldering iron. I'm going to solder this middle leg. Soldering iron's a little dirty there. Clean soldering iron. That's the secret to everything. Get a little solder on there. Get it to the middle leg. And that'll get it held in place, and then you can kind of straighten your legs back up to get a good solder to them. Sometimes you need to straighten them, sometimes you don't. And I have a, if you notice, you'll see me using a green pair of nippers, and then I have a red pair of nippers. My green ones, the tips all messed up, and so they're kind of general purpose. When I need to do exacting, I got a new pair, and I use them exclusively for snipping off leads, nothing else. And so I'll come in here and I'll get a hold of the lead, and I'll snip it off flush and make sure I keep track of it. That way I don't end up with one of these leads stuck somewhere in the board to short something out. If I don't have 6 leads, when I've cut 6 leads off, I go looking for it until I do. That's why I like to get a hold of it. So let's go on ahead, and if we stick the camera right there, maybe. And install. New pot. Make sure it's firmly seated all the way down. Let's see if I can get that right there. Yeah, it's in that little view. Get my solder ready here. Hopefully you can see that little view. I could maybe expand it a little here. If I move this over and this, there we go, and then take this and make it a wee bit bigger. There you go. So I want to pick one. I want to get a little solder. Clean up my iron real good. Get a little solder on my iron, just a tiny bit. I touch the leg. I touch the leg with the solder. And then you should end up with a nice perfect joint. Because it'll flow down and it'll get that little via hot. And ba-bam. Nice little solder joints. Alright, let's shrink this back down a little and switch our view, turn that off so I can move that camera out of the way. And that got that one in there. And you'll see, well, this right here is thermal compound coming off of here, but you'll see there's some like white residue on this right here. Can you see that? Oh, yeah, okay. From the isopropyl alcohol. That's why I do my final clean with acetone. Acetone does a little bit better job cleaning and doesn't leave a residue. So I could show you that real quick. Get out my acetone. And I'll dribble a little in there. It's much easier to control in that little. You can see, I'm going to clean up where we soldered those in. Real nice. Sometimes you have to spin the sucker in there in your fingers to keep the fibers from going crazy. And just clean it up and clean up where you've touched it. And then if you get a fiber, I don't have any fibers. Anyway, little pair and pull it out. So that gets that. So now we put away our 56, our A56s. And we get out our, make sure we have our A06s. And if we look at our little card, we got A06 there and there. And yep, we still got those holes open. So we haven't confused anything. And so it pays to do it, for me anyway, it pays to do it methodically. So I don't screw up. Like I said, I do this as a hobby, not as a living. Some of the guys that are really good at this, you know, the repair techs you guys are going to find to fix your stuff that you don't want to try to attempt yourself, are going to probably be a little better at this than I am. But everybody's got to start somewhere, and it is really, really fun to me to get a dead amp and make it work. And so we're going to push them down in there, and I'm getting thermal paste all over my hands. The cheapest paper towels from Walmart. Super duper valuable. Focus. Will it focus? No. Oh yeah, beauty. I'll even make that a little bigger there for you. Really wanted to do some of these shots like this, and I've been practicing and working on some of this stuff to try to help let you at least see what I do. It may not be the best way to do it, but it works. There we go, nice little solder joint. They should end up nice and shiny. See if I can slide right over to this other one. Yeah, there we go. You'll notice I don't talk much, or you may hear a slow exhale. Since I'm not running my fume extractor, I just hold my breath so I don't get fumes, or I blow them away from me. And so let's shrink this back down and switch the cameras. And we're going to go back to snipping. Slow and tidy work, but it's fun when it all works. I'm going to clean up. I'm going to kind of give it a pause here and clean up the bench and get it all flipped over and ready to look at these waves again. And there we go. I'll clean this all up. I got the old transistors and the old pot and everything. There's the old pot. Clean this all up real quick. We'll fade, come back, and we should be ready to look at some signals. So, while I was working getting this stuff in, was getting ready to test, I noticed something. Let's see if I can get the little camera over here. I'm probably going to have to do the zoom. And let's see if the big picture helps. Yeah, right there. Oh, come on, stay focused on that resistor. There we go. See that little crack in there? Yeah. That's not good. Might be changing the resistance value, may be bad. Remember, we were trying to get up underneath these with my little pointy probes even, and I was having trouble and stuff. So I grabbed another one off of a spare board. I actually, thanks to Chaz, have a parts board or two now finally, so I don't have to stop what I'm doing every single time I don't have a part and order it and wait to do the video. So these are on this, they are the source resistors. You'll hear me call them like emitter resistors all the time, because emitter resistors is when they're done with transistors. These are FETs, so these would be a source resistor. So anyway, they're super low ohm. This is a brown, black, over here, brown, black, silver, gold, and so it's going to be a 0.1 ohm resistor. So when you do this, you need to put your multimeter on the lowest ohm setting. 200 is lowest, and you need to hold real tightly together your meter, and mine reads 0.3 down to 0.2. So that's the resistance of my leads and everything else. So you go to measure one of these, and you need to hold it down real tight on there. And so now it's measuring 0.3. So if we take my 0.2 from my stuff and the 0.1 from this resistor, it should read 0.3. So this one's good. While I'm doing all this, I'll go ahead and take this board back out real quick and desolder that. I'll put this one in, and then I'll leave this one out, and we'll test it when I get done. I'm trying to cut out all the fluff stuff here, so I'll go ahead and change this real quick for this one. Bam. And then I'll leave this out, and we'll measure it and see if that is part of our problem. We may be starving a little bit of this for voltage, so I'll see you when that's done. All right, so I swapped out that resistor, and I got the other ones here. So let's hold our probes here. We're going to get down to about 0.2, and we're going to measure on these resistors. Uh-oh, that was one I took out, and you notice I got a second one out here, and that one nothing either. So what I did, meter out of the way. What I did, we were that was the one that we that was this cracked one right here, had the crack in it. So I replaced it, and I thought, okay, so we had these outputs blown. Let's see, what are those? The 9650s, these two, and these are the these are 9540s, sorry, 9540s, and these are the 540s. All had the little blown driver resistor. All the FETs blew, so we replaced those. We went ahead and replaced the drivers, but with these being bad here and here, we probably might not have had to replace the drivers, although it's a really good idea too, because these cost anywhere from like a quarter to 50 cents for some high-end ones and weirdo ones. But let's probably say a quarter, so that's $1, maybe $2 worth of parts. And it's a good idea, especially when the FETs die, to go ahead and replace the drivers. And super especially if you have any gate resistors die, because that means these took a hell of a blow. So we went ahead and I replaced both those, and I put it back in the heatsink here real quick. I haven't bolted the actual board, but I went ahead and did that. And so let's feed an input signal, turn on the power, and get the scope up on here. Now we are feeding it. Let's see if I can change the voltage. We are on max voltage there, so we are feeding it this, a 60 hertz signal, and so we're going to look for 60 hertz on the output. So we're going to look for this light to come on, and there we're on, and we're going to look, and there is the good side. You see 60 hertz coming up there, and that's going to be evident on the positive terminals of the speaker outputs. So let's see what we have over here. Looky there, looky there. It's amazing what happens when the FETs can get power. So let's shut off power. Let's change to, let's get this cable carefully out of the way. Let's go ahead and plug in some music. Grab the speaker wire. Let's go ahead and turn it on. And the positive and negative. Now this was the good side. Oop. We do not have low pass on. And I want low pass on so that nobody can recognize the music and I don't get any of those music strikes. So 80 hertz low pass. 80 hertz low pass. And now let's see here. All right, I can turn that up a little. And then let's go to this one. And then this one. Amazing. Sweet. We have music. And we'll just go ahead and put the scope on there. That's what music looks like. That's the bass. So that's the song that's playing right now. Change the dial a little here and get it a little bigger. But that's what music looks like when it's playing through. So let's see. The gate is right here. I want to show you. There is nothing on the gates of these FETs. And that is weird to me, and I haven't quite figured out how Rockford does this yet. I just know that I keep working on it until I get the good signal towards the output. But Rockford's little signal here to drive their FETs is really unique. It may not be unique now, but back in the day it was really unique. They were one of the first ones to use FETs for their outputs. That was back in the Punch 45, MOSFET days, Punch 150, stuff like that. Anyway, it's really cool, and I've not figured out how to follow the signal perfectly. One thing I did want to do was let's go ahead and grab this and turn the voltage down so you can see the music playing. That's what the music looks like coming in. And then remember how I talked that these opt amps, if you look up an opt amp, which these are, if I get my old man spectacles out here, TL072s, if you really careful and find the output, I'll have to turn the voltage a little more. You can just barely see it on there. I'd have to adjust it, but it goes through all those. And if you look at the op amps, you can trace that all the way through. And it actually, the front channel, one side, this side goes through that one, that one, that one, then that one. This side goes that one, that one, that one, and then that one. And then it goes out in to be driven. And so I'm still learning the output section. Like I said, I'm new to all this. I'm not an expert by any stretch of the imagination, but since we replaced these and redid the drivers and stuff, I off camera I'm going to go ahead and double check my bias settings. I'll probably crank them back and redo them there. Now the bias setting that I showed you how to do, that's the poor man's way with a multimeter. And you can do that basically on any amp, and that's really handy if you don't have an oscilloscope like that right over there. Now I know there, and I've played around with it. There's a professional way to do it. You send no signal into it, just like you do whenever I'm doing it, except you need to be grounded with your oscilloscope. No. Sorry, you do send a signal into it. There's another way to set them. No load. There's always no load to set the bias. You put a signal sweep going through it, so it runs all the way through the audible spectrum, and you will look at the sine wave, which you've seen that sine wave that we just had. That was perfect on the scope. That went. You'll change the bias until you see that there's a little notch in the middle, and maybe in one of my videos I'll get a chance to do that and show you the actual notch, and you make that notch go away. And that's the way the pros that are setting up a really fancy amp for everything they go, if you get a really high-end amplifier, super sound quality, not going to be super huge important on this little 4-channel right here. We did it that bias adjustment way is the safe way to do it. It's going to play good quality, no problem like that. We're just not trying to squeak every last 2 watts out of it and absolutely everything like you would maybe a Soundstream Class A reference type amp. So, you know, this is plenty good, especially for a hobbyist, and getting it up working. And as you build your skills, you could always go back and feed it in and tweak it ever so slightly. But Rockford's potentiometers are so coarse that it's really hard to do a super high-end tweak if you really wanted to do what the pros do when they're really trying to make an amp perfect. As a lot of times if an amp had pots like this, they'd actually replace them with more precise pots that gives them a much better turn range so they can do that better. You know, Rockford builds theirs kind of more brute force to handle it, so that it's kind of rugged. You just get it really close that way, and away it rocks. So this sucker is playing music. I'm going to double check a whole bunch of stuff on it, and like I said, double check that bias setting, and I'm going to stick some loads on it and let it cook. And this will go back to Andy. So Andy, if you're watching, your amp's fixed and it's going under load testing. So if I get that done tonight, I'll bring it by tomorrow. Special shout out to Chaz again, thanks, because now I have a parts amp and I was able to snag those out of it immediately and get this sucker wrapped up tonight. So thank you, sir. So everything we did, quick review, stiffened up the remote turn-on terminal just in case. We replaced this side, these 2 channels worth of FETs and their drivers. May not have needed to do the drivers, but we did anyway. And then I discovered that the source resistors, I like to call them emitter resistors, but these are FETs, so the source resistors, 2 of them were dead, and so replaced those. We also had to replace 2 of the drivers on the 9540 FETs. The gate drive resistors needed replaced, and then we had to replace this gain because it was all wonky and wouldn't read right. And I got that over here. I'm going to take it apart and see if it's all bent and mangled in there, just because I'm curious. And then we had to remove the RCAs and repair them because it got smacked and it broke several of the pins. And so we did all that, cleaned all the switches and pots, and like I said, I'm going to tighten everything up, double check a few things, and put some load to it, and she will be done. If you found this interesting, we're going to do a lot more Rockfords. We're going to do some that have, I'm going to try to get one that's got transistors, not a Rockford, but because actually that's what I recommend you learn on, because it's really easy to follow the signal path through them and everything. You can get your base understanding of an amplifier a whole lot better, and then you can start playing with these. Once you're kind of comfortable, even if you don't 100% understand, like I don't, I'm not an expert on how Rockford drives these suckers, but I do know, you know, replacing certain drivers. I know where to look for good signal and then go back and keep looking for bad components, especially if you have a good channel to compare it to. So that helps you go. And then we'll do some, I'm going to try to get some more Class Ds and do a couple of those also. And so I hope you learned something. I hope it was fun. I think this is going to be a pretty long video, but I think everybody's wanting to see it finished. I know Andy is. Excuse me. So anyway, if you like these things, comment. We will not be doing the 801S, and I'll show you why in the beginning of the next repair video. It is power supply transformer is completely cooked, which also runs the core. So I'm going to have to find either a sacrifice board or something. But the boss is in here, so you can see the boss. So she's needing a little love. So I'm going to play with the dog for a minute, and then I'm going to get this sucker rolling. And like I said, comment, like, subscribe. Thanks for watching. Hope you learned something. If not, I hope you screamed at your screen and told me I was doing it wrong or something like that. I'm just a goober. Thanks for watching, like I said, and see you next time.